Hello people, good evening to everyone. So today we are going to see most probable expected models of questions based on this computer network subject. And you know that this particular 2022 examination is going to conduct by IIT Kharagpur. Okay. And first of all, let me welcome you all to ACE Preparation League. Right. So coming to the first weightage of this computer network subject, and then I can give the overall computer networks with respect to all previous year papers. Okay. So verify. So this is the pie chart which you can get an idea what exactly computer networks weightage is. So you have computer networks is having a vast syllabus with respect to GATE examination. I hope you are aware of that. So among that vast syllabus, you can have, so from which topic we can get more probability to get the questions, or else which topic is having more weightage. So might be that that thing can be running in your mind, so that questions might be running in your mind. So the answer for those questions is this pie chart. So if you verify this entire portion is data link layer. So from data link layer you have 23%. This is all. I mean, this analysis for previous all papers with respect to all previous year papers. Okay, and from 2003 to 2021 GATE examination, we have done the analysis. Based on that, we are giving this pie chart to you, and it can be very helpful to you, I believe. So this is what the percentage of weightage from data link layer. And coming to the network layer, so this is what entirely network layer. And of course NAT also, okay, of course NAT also. So coming to this and this, totally it is 32%. And then the another layer we have which is a transport layer. From transport layer, we have 30% of the weightage. So look at, if you prepare only these three layers, what are the three layers? One is data link, another one is network, and another one is transport. If you prepare these three layers, it is enough. 85% of the syllabus, 85% of the computer network syllabus is being covered by you. Fine. And the rest of 15% is, you can observe, there is one more concept which is concept of layering, you can say. So concept of layering means ISO OSI reference model, TCP IP reference model. So if you verify all the previous year papers, there is a hit rate of 90% of hit rate, or else 95% of hit rate to get a question from this concept of layering, 1 mark questions. Okay. So this is what so I can say both this application layer protocols and this concept of layering and switching also. Look at switching also. Collectively total 15% from these topics, concept of layering and switching, concept of layering and switching. Collectively you have 15% of the weightage. And data link layer 23, network layer you have 32, and transport layer you are having 30. So this is what the overall analysis of computer network subject with respect to previous year papers, right? Let's look into IIT Kharagpur pattern. So if you consider IIT Kharagpur computer networks paper, if you verify, in 2014 paper from computer networks we have 9 marks. You know that in 2014 we have 3 sets, set 1, set 2, set 3. From all these threads, from all these 3 sets, average we are having 9. And in 2006 we have 10 marks. So overall, IIT Kharagpur is having the weightage for the computer networks like 9 to 10 marks. This I can give. So we can expect 9 to 10 marks of worth of questions from this computer networks paper, computer network subject in GATE 2022 examination, right? And look at what are the topics this IIT Kharagpur have focused during these 2 years, that we are going to see in our next slide. So look at, so if you verify, in 2006, we have question from data link layer, that is specifically from flow control, stop and wait and sliding window. From flow control topic, we have 2 questions. From network layer, if you verify, IPv4 addressing, we have 1 question. And connecting devices, CDs in the sense connecting devices like bridges, routers, and etc. So from that we have 2 questions. So this is what. Next, if you verify 2014 paper, from concept of layering we have 2 questions. From data link layer we have 2 questions. And from network layer we have 2 plus 3, 5, 5 plus 2, total 7 questions. I mean, this is what, 3 sets of analysis it is, okay. 7 questions we have from network layer among the 3 sets of 2014 paper. 2 questions we have from data link layer among the 3 sets of 2014 examination paper. And 2 questions are there from concept of layering among the 3 sets of 2014 question, 3 sets, okay, 3 sets. Similarly, coming to transport layer, 2 questions we have among 3 sets of 2014 examination paper. And finally, we have one time of question from switching, which is packet switching based on that. That is what I mentioned, PS, packet switching, right? So this is what the analysis which I can give, and might be it can be helpful to you, right? So now based on this, we are going to focus all our, this entire session on tomorrow's session, we are going to focus on 3 layers only, mostly 3 layers. From 3 layers we are going to discuss. So data link layer we will be discussing, network layer questions we will be discussing, and transport layer questions also we will be discussing in these 2 days, so that it can be benefit to all of you, as it is a quick revision you can consider, okay? Right, so I hope you are all ready to start answering the questions, right? So look at the first question. This is the question we have from concept of layering. This is the question from concept of layering, okay? So look at this question statement and let me know what is the answer for this. So while sending the data of P bytes from the transport layer to the physical layer, on every transport to physical, H bytes of header is uploaded. The overhead percentage due to the header on the link is, the size of the P is 4 times of header. So this is what the question you have. So let me get replies from you. So can I know what is the answer for this question? Waiting for your responses. Yes, Kushendra, good evening. So what is the answer for this question? So I'm going to start the explanation for this question, okay? I'm going to start the explanation for this question. Look at, you all know that with respect to the network software, system is a set of layers, right? With respect to the network software, system means it is set of layers. It means that I can have application layer to physical layer here. So let's say application layer, presentation layer, session layer, then transport layer, then network layer. After that I have data link layer and then physical layer. So you all know this, right? So with respect to the network software, system means it is a set of layers. So set of layers I am having on both sender side and receiver side. So application, presentation, session, transport, network, data link and physical. Okay? So now look at, so what is the question? It is saying that from transport layer to physical layer, the message has been traveling, let's suppose. So from transport layer, from here, the message has been traveling, right? So means that what is the message size it is mentioned? The size of the P is 4 times of header. So P is 4 times of header. So how much length of the header we are appending? H bytes of header we are appending, right? So it means that the P value is 4 into H. P value is 4 into H. And how many layers it is traveling? 4 layers. It is saying that from transport layer to physical layer. So transport layer header can be there. Network layer header, let's say if you consider this is a transport layer data portion and it can have header here, right? And if you consider a network layer, this is the network layer message format. Here I can have header. This entire one can be encapsulated into the data field, right? Next, coming to the data link layer. So data link layer message format is this, like you can say that the frame. So here it can have the tail part and it can have the header part, and here we have data portion. This data portion is filled up with the whole message of the network layer. Am I correct or not? So means that, and coming to the physical layer, so this physical layer header is appending to this, right? So this is the physical layer header. So total, how many headers have been appended to the message? 4 headers have been appended. So now this is the message, and for this message 4 headers have been appended. So this is what your total message that is going to be placed onto the channel. So now this is my channel. Onto this channel, this whole message is being placing. Headers plus messages. How many headers? 4 headers plus 4H message. So total 8H. 8H message is being you are placing onto the channel. But the question is asking about the overhead percentage due to the header on the link. Due to the header on the link it is asking. So it means that what is the overhead that is been happening here? 4H is the header part. So this is the header which is overhead. So and this is the total. So out of 8H, 4H is the header. Correct now? So this is what the percentage of, this is what the overhead percentage due to the header on the link is equals to 4H by 8H. So 4H by 8H, HH gets cancelled 1 by 2, which I can write as 50%. So 50% is the answer for this question. 50% is the answer for this question. I hope everyone is clear with this. Okay. So Rishikesh, please verify. 25% you have given. 50% it is given. It is the answer 50%. Rishi, right. Right. So I hope everyone is clear with this question and the corresponding explanation. Let's move to next question. So look at this question. This is the question from we have network layer. Look at the question statement. A TCP message consisting of 2100 bytes is passed to IP for delivery across 2 networks. The first network can carry a maximum payload of 600 bytes per frame, and the second network can carry a maximum payload of 400 bytes per frame, excluding the network overhead. Excluding the network overhead. Okay. Assume that IP overhead per packet is 20 bytes. What is the total IP overhead in the second network for this transmission? Option A 40 bytes, option B 80 bytes, option C 120 bytes, and option D 140 bytes. So what could be the answer for this? What could be the answer for this question? So it is saying that there is a TCP message consisting of 2100 bytes is passed to IP to deliver across 2 networks. So according to this particular line, what it is saying that the diagram you can draw like this. So how you can draw the diagram here? The diagram you can draw here, like you can have 2 networks here. So let's say this is the first network and its corresponding MTU. Okay, this is the first network and its corresponding MTU. And this is the second network and its corresponding MTU. This is the second network and its corresponding MTU. Okay, right. So what is the first network MTU it is given? Look at the first network can carry a maximum payload of 600 bytes per frame, and the second network, so this is having 600 bytes. Okay, and the second one is having 400. So the 400 bytes. 400 bytes. And it is clearly mentioned, look at, clearly mentioned it is excluding the network overhead. It means that we are not considering 20 bytes in as part of this 600 and 400. Okay, excluding. So it means that 600 plus 20, 400 plus 20. That is what the meaning. So this is what the data portion, 600 bytes and 400 bytes of payload we are having. So now, if you consider this is the network 1 and this is the network 2. So what is the message you are being transferring? 2100 data portion you are transferring, right? So now look at, this is the message which is having length of 2100. So 2100 at a time can we forward from this end to this end with the MTU of this? We can't. It means that we need to do fragmentation here. So how many fragments it can create? Look at, so 600 at a time I can transfer 600 here. So 2100 I can fragment this. After crossing this network, I can have how many fragments? I can have 4 fragments here. So what are the 4 fragments? The first one is 600, and the second one is also 600, and the third one is also 600. So with this 1800, and the last one is having just a 300. So this 2100 bytes of message is being fragmented into 4 fragments at network 1. Okay. Now these fragments we are passing through network 2. So coming to this network 2, MTU is 400. means this 600 we can't transfer at a stretch from this end to this end. So it means that the 600 needs to be fragmented now. So how this 600 can be fragmented on the second network? One is 400, another one is 200. Correct now? And the second fragment also to be fragmented into 400 and 200. And the third one is also going to be fragmented into 400 and 200. But this one, if you verify, 300 is less than the 400. At a stretch you can transfer, right? So at a stretch you can transfer. So 300. So total, how many fragments you are identifying here? 400 plus 200, 400, 200, 400, 200, 400, 200 means 6 packets, 6 fragments, and the 7th one is 300. So for each one, we are appending 20 bytes of header. We are appending 20 bytes of header, correct now? So then, the question is asking about what? The question is asking about what is the total IP overhead in the second network, total IP overhead in the second network for this transmission. So we have 7 fragments here. For each fragment, 20 bytes of header is being appended. So that 7 into 20, 140 bytes. So 7 into 20 bytes, which is 140 bytes. So 140 bytes is the answer for this question, which is matching with option D. Option D. Okay. So let me check it out how many have given the answer here. Yes, Nitin Kumar, please verify you have given me 120. Kindly verify this. This is 140. Okay, 140. Nitin. So I hope remaining people you have got the concept of this question, how we are solving. Yes or no? So I hope you are all clear with the explanation of this question. Let's move to next question. So look at this question, please. This is the question from network layer we have. This is the question from network layer we have. Okay, this is the question we have from network layer based on routing concept. So verify the question here. So for the network given in the figure below, the routing tables of the 4 nodes A, E, D and G are shown. So what is the meaning of this line? This line is saying that 4 routing tables are given. This is the routing table for A, this is the routing table for D, this is the routing table for E, and this is the routing table for G. It is saying that, okay? Next, suppose that F has estimated its delay to its neighbors A, E, D and G as 8, 10, 12 and 6 milliseconds. So from F to A, it is estimating it as 8. From F to E, it is estimating it as 10. From F to D, it is estimating the cost as 12. From F to G, it is estimating as 6. Okay, right, respectively, and updates its routing table using the distance vector routing technique. Fine. Then, what is the next question? What is the second part of this question? Look at which of the following is true with respect to the routing table of router F, and it is a MSQ question. Please identify this. Please observe this MSQ question. Okay. So one more time, I'm showcasing that question to you. Look at these are the 4 routing tables we have, and F have estimated the cost for A, E, D, G as 8, 10, 12, and 6. Then it is asking about some information related to the routing table F. Which of the following are true, it is saying. So please consider this question and data and focus on this question. Which of the following is true with respect to the routing table of router F? Option A, it is mentioned that the distance from F to C will be stored as 28. Option B, it is mentioned that the next hop router for a packet from F to B is D. And option C, it is mentioned that the distance from F to B will be stored as 30. And option D, it is mentioned that the next hop router for a packet from F to C is E. Okay. So what is the answer for this question? Right. So it is asking about F2C, F2B, F2B and F2C. Okay. So means routing table of F we have to consider first. Right. So let's look into this. So first let me draw routing table for F. So I am having how many routers here? 6 entries should be there. So F, A, B, C, D, E, F and G. Okay, right. So F to F it is 0. F to F it is 0 because if you verify A to A it is 0, D to D it is 0, E to E it is 0, G to G it is 0. Similarly, F to F it is 0. Next, F to A it is given as 8. F to E it is given as 12. F to D it is given as F to D it is given as 12 and F to E it is given as 10. And F to G it is given as 6. Right. So we need to calculate the distance vector of this B and C. I mean, we need to calculate the cost for F2B and F2C. With that, we can complete F's routing table. Okay, right. So verify from F. What are the neighbors I have? So from F, A is one neighbor. So that I can go to the from F, then I can go to A, then I can go to B. So from F to A, it is 8. And then A to B I can go. So from F to A, what is the cost we have? 8 plus A to B, what is the cost we have? 40. So which is 48 it is. Right? Next, F2, we can consider D. F to D and then I can go to D to B. F to D the cost is 12. And D to B if you verify, 8, which is 20. Okay. Then F2, I can go to G. Okay. F2 I can go to G. Then G2 I can go D and then I can go to B. So if it is further more cost, comparatively this 20, right? F2G, what is the cost we have? F2G, the cost is 6. G to D, if you verify, 19, and D to B, if you verify, 8, which is going to be 33, no? 19 plus 5, 6, 25 plus 8, 33. Right? So now look at which is the shortest cost we have. 48, 33 and 20. Which is the shortest cost? This one will be saved. 20 will be saved. From F to B, 20 is the shortest cost. But what is the option A it is specifying? The distance from F to C will be stored as 28. The distance from F to B will be stored as 30. Look at, is it stored as 30 here? No, it has to be stored as 20 only. But it is mentioned that 30 here, right? So hence option C is not an answer for this. I mean, it is false. We need to find out the true statements. It is false. Next. Next, look at the next hop router for a packet from F to B is D. Is it correct or not? F to B is D. Verify. Yeah, F to B next hop router is D. Then only we are having shortest cost. So it means that option B is true here. Option B is true here. I hope you are getting me, right? Next, F to C if you verify. I want to travel now F to C. So F to C, if I want to travel, look at, so first F to C I want to travel. So I can go first F to A and then A to C. F to A, what is the cost of F to A? F to A, it is given as 8 plus A to C. A to C, it is 14, 22. Okay. Next, F to E, I can go and then E to C I can go. So F to E, what is the cost I am having? 10. Plus E to C, it is given as 7, which is 17. Okay, F to E it is 10 and E to C it is 17. Next, What is the next way, next path I am having? F to D, then D to C. F to D, I have 12. F to D I have 12. Then D to C I have 30, which is 42. 42. Okay. Which one is the shortest one if you verify? 17 is the shortest one. And it is possible via E, right? So verify the options, verify the options now. The distance from F to C will be stored as 28, okay? And the distance, the next hop router for a packet F to C is E. Look at F to C, it is E. Yes, it is E. F to C, the shortest cost is 17, and the next hop is E, which is correct. So option D is true here. Option D is true here. But if you look at option A, F to C, what is the cost we have? F to C we have 17, but it is given that 28, which is wrong. So as we need to calculate the true statement, option B and option D are the true, so that B comma D are the answers for this question. B comma D are the answers for this question. Okay. So I believe you are clear with this. Yes, Lena have given B and D. Good, good. Right. So let us move to next question. Okay. Right. So next question. So look at this question. It is also MSQ based question. Statements is true about TCP. Which one of the following statements is true about the TCP? Option A, it is mentioned that TCP reacts to the congestion by reducing the center window size. Option B, it is mentioned that the size of the advertised window never changes during the course of TCP connection. Option C, in TCP's slow start phase, the transmitter's transmission rate is slower than TCP's additive increase phase. And option D, the packets of the same session may be routed through different paths in TCP. So this is also MSQ type question. Okay. So what is the answer for this? Please verify. What is the answer for this? Look at first, TCP reacts to the congestion by reducing the sender window size. Is it true statement or not? Yes, it is true statement. How we can say that it is true statement? You know that TCP can handle congestion in 3 phases, like additive increase phase, multiplicative decrease phase, slow start phase, right? So first it starts with the slow start, then it goes to the additive increase, and then it goes to multiplicative decrease. So in slow start phase, we have exponential growth in the congestion window size. So if we continue this exponential growth in the congestion window size, then we can face the congestion. So that is why what we are doing, we are allowing this particular congestion, exponential growth in the congestion window till some congestion threshold, right? So after that, it is been incrementally, it is going on. But this incremental growth or else linear growth in the congestion window is continued until timeout. What is the timeout means? Timeout means congestion is detected, which is multiplicative decrease phase. Congestion detected. So when the congestion is detected, then what you are doing? You are calculating the congestion threshold for the next round of slow start. Like congestion threshold is equals to congestion window by 2. Getting my point or not? So so that is what. So TCP reacts to the congestion by reducing the center window size, which is correct. So you are bringing that particular window size again drops to initial size. After timeout is occurring, whenever you are finding that there is a timeout, then you are calculating the congestion threshold for the next round of slow start, and then you are bringing that congestion window size to the initial size. Getting my point? So hence it is the true statement. TCP reacts to the congestion by reducing the center window size, which is correct. Next, option B, the size of the advertised window never changes during the course of the TCP connection. Is it true? No, it is false. How it is false? How it is false? Because the receiver can have its own buffer, and this buffer, the receiver is advertising its buffer, something like few amount of buffer it is been advertising. So that advertising window, that advertising window can be changed with respect to certain conditions like network traffic, receivers capacity, etc. So depends on them, the advertised window can get changed. But it is mentioned that never be changed. So depends on the network capacity or a network traffic, you can say network traffic and receivers capacity. Based on that, the advertised window gets changed. But it is mentioned that never changed. Hence you can say that it is false statement. Then option C, if you verify, in TCP's slow start phase, the transmitter's transmission rate is slower than the TCP's additive increase phase. Is it true? No, it is false. It is false. How you can say that it is false? Because in slow start phase, the sender window size, the congestion window size, you know that the sender window size is being a minimum of congestion window and the receiver window, you know that, right? So that sender window size is being incrementally increasing. In slow start phase, the sender window size is being, the congestion window size is being exponentially increased. So since it is exponentially increased, the transmission rate of the sender can be faster, because every time the sender transmission is getting doubled. For every round trip time, the sender window size is getting doubled. Are you getting my point? So it means that, but in the case of slow start, in the case of additive increase phase, it is linearly incrementing. So what can be the correct statement here? In the TCP slow start phase, the transmitter's transmission rate is faster than TCP's additive increase phase. It is correct, but it is mentioned that slower. Why it is faster? Might be that is a doubt. Why it is faster in the sense there is an exponential growth in the congestion window size in the case of slow start phase. But in the case of additive increase phase, we are having linear increase, okay, linear growth. So linear growth is a slower increment comparatively exponential growth, right? So hence this statement is false. Next, look at option D. Packets of the same session may be routed through different paths in TCP. Is it correct or not? Yes, it is correct. It is correct. How we can say that it is correct? You know that IP network layer we are having, this is my transport layer and this is my network layer, and in this network transport layer I am having the TCP packets here. So this is TCP header and this is the TCP data portion. This is the TCP packet. And in the network layer I am having IP datagram. This is the IP datagram header and this is the IP datagram data portion. Into this, these transport layer protocols messages are being encapsulating. And this is my IP here, right? This is my IP. And you know that this IP is connectionless protocol. So since this IP is connectionless, in connectionless networks, how the data transmission can be traveled? In multiple paths, because for everyone we are appending the header. So hence the packets of the same session may be routed through different paths in the TCP is a true statement, because the TCP packets are encapsulating into IP packets. So that it is a true statement. So overall, as it is a MSQ question and we need to identify the true statement, option A and option D are the answers for this question. Option A and option D are the answers for this question. Okay. So let me check it out how many I have given. Yes, Leena have given option A and option D. Very good, Leena. Right. So next, coming to the next question. And rest of people, please try to give the answers. Try to give the answers. So look at this question. This is the question from again network layer we have. Networks A, B, C respectively. Host X sends the data of size 1480 without 1480 bytes without 20 bytes of header in the to the host Y. See, verify, concentrate on this sentence. Concentrate on this sentence. The host X sends the data of size 1480 bytes without 20 bytes header to the host Y. Okay. The network ABC have MTU of 1500, 200 and 400 MTU. MTU includes the header size here. Okay. MTU includes the header size here. The size of the header is 20 bytes. The size of the header is 20 bytes. The total length of the last fragment that can be received by host Y is, this is what the question. So last fragment total length it is asking. What is the answer for this? What is the answer for this? Please verify. Roy, Rishikesh, Leena, Nitish, please do response. And Kushendra, what is the answer for this question? So here it is mentioned that there are three networks. Look at, this is the network A, this is network B, and this is network C. Okay, 1500 bytes, 200 bytes, and 400 bytes. MTU of network A is 1500 bytes. Network B, MTU is 200 bytes. Network C, MTU is 400 bytes. Okay, right. So this host X is sending how much data? 1480 bytes. So this is sending 1480 bytes of data here. And you know that MTU includes, it is clearly mentioned, the MTU includes header size. What is that header size? 20 bytes. So this 1500 bytes I can split like 1480 bytes of data plus 20 bytes of header. So this is header and this is the data portion. Correct now? So now the host X is sending 1480 bytes of data. So at a stretch, can I forward this 1480 from this end to this end or not? Onto the network B, I can transfer total 1480 at a stretch here. Yes, I can transfer, so that it means that there is no fragmentation is happening at network A. So directly this 1480 bytes of data is being arriving to the network B now. So now this network B, is it able to transfer 200 bytes, is it able to transfer 1480 at a stretch from here to here? No. So then, but how much it can transfer from this end to this end? So 200 bytes is the MTU. 200 bytes is the MTU in the sense, among the 220 bytes is header. And if you consider 180 is not divisible by 8. You know that why it has to be divisible by 8? Because fragmentation offset needs to be expressed in terms of 8 bytes. So the MTU portion, the data portion of the MTU should be divisible by 8. Okay, but 180 cannot be divisible by 8. Then the closest value I have to consider, that is 176. So it means that this is going to be divided into 176 plus 20. So this 1480 is going to be divided into 176 fragments, right? So 176 worth of data in each fragment. So if you verify 1480 divided by 176, if you do, you are getting 8.4. It means that 9 fragments is being created. 9 fragments is being created. 9 fragments is being created. So among the 9 fragments, 8 fragments are having full 176 bytes. 8 fragments are having full 176 bytes of data. And the 9th fragment, which is the last fragment, it is going to have how much? Verify. So 176 into 8, 1408. 1408, out of 1480, 1408 is part of 8 fragments, right? So then remaining 72 bytes can be part of the 9th fragment. So now these 9 fragments is being transferred to the network C. Network C is having 400 bytes of MTU. 400 bytes of MTU, how can I split this? 380 plus 20. But is 380 divisible by 8? Is 380, if you verify, is 380 divisible by 8? No, it is not divisible by 8. Then we need to consider the closest value. So what is the closest value? If you consider 376, yes, it is divisible. So means that this MTU is being divided 376 plus 20. So now these 9 fragments data portion, whatever the data portion we are having, 9 fragments data portion, that 9 fragments data portion, is it less than the 376 or not? Verify. 8 fragments having the data portion of 176, which are all are less than this 376. It means that all 8 fragments without fragmentation I can get here. All 8 fragments which are having 176 bytes of data, can be transferred from this end to this end without any fragmentation. And the last one, which is ninth one, 72 bytes we are having. This is also less than the 376, so that at a stage we can transfer, right? So means that the last one, which is the ninth one, is also having 72 bytes of data. 72 bytes of data, correct now? So 72 bytes of data. So this one, if you verify, the last one it is asking. So what is the total length of the last fragment that can be received by host Y, right? So what is the last one? What is the last one size? 72, and it is asking about the total length, na? Total length. It means that needs to be add 20 bytes of header also. So that the total length of this last fragment is going to be 92 bytes. 92 bytes. Okay. So 92 bytes is the answer for this question. Verify 92 bytes is the answer for this question. Yeah, Leena, it is asking about total length. It is not asking about the data length. Okay? It is not asking about the data length. Unnati, you also. It is asking about, yeah, Priyanshi. It is asking about total length, ma. Total length it is asking. It is not asking about the data length. Please look into that question statement. It is asking about the total length. Total length in the sense, you know, what is the formula for total length? Data length plus header length, right? Data length you have 72 and header length is 20. Total you are getting 92 bytes. So 92 bytes is the last fragment data total length. Last fragment's total length it is. Okay? I hope you are clear with this. Okay? If the question have data length of the last fragment, then 72 can be the answer. But it is mentioned that total length. Okay? So hence the answer is 92 bytes is the answer. Okay? Right. So I hope you are clear with the explanation of this. Let's move to next question. So look at this question. This is also MSQ. This is also MSQ. And mind that we need to find out the false statement. We need to find out the false statement. Mind this. So please do, please look into this question and try to solve and give me the answer for this question. So what is the answer for this question? So consider an IP address 12.16.4.75//22. Which of the following is false about the given IP address? It is a given IP address which is in CIDR form, okay, which is in CIDR form. Which of the following is false about the given IP address? Right. So the first one, it is saying that the subnetwork address is 12.16.4.0. Is it true or not? Verify. So subnet address, what I can say? Subnet address is the first address of the subnet or not? Subnet address is also called as the first address of the subnet or not? Yes. Similarly, you can say network address is also called as the first address of the network. In the same way, subnet address is also called as the first address of the subnet. Okay? Right. So now I am going to calculate the first address. So in CIDR, how can I calculate the first address? Try to recall. So to calculate the first address, I need to set 32 minus n number of rightmost bits to the 0. I need to set 32 minus n number of rightmost bits to the 0. So where n is what? Mask bits or else prefix. So here this is prefix n. This is n. So 32 minus n, 32 minus 22, 10. The last 10 bits I need to set to 0. Verify. So 12.16.4.75. How can I write 75? Verify. So 64 plus 11. 64 plus 11, right? So 0100, 1011. This is 75, I believe. So 64 plus 8, 72. 72 plus 3, 75. Correct. So 75/22. Right? So I need to set the last 10 bits, I need to set to 0. So 12.16.0000, for how can I write 0100 dot 01001011/22. Last 10 bits I need to set to 0. These are the 10 bits I need to set to the 0. So if I set these 10 bits to the 0, then what would be the result? Have a look. 4 times of 0, 0, 1, 00, all zeros. Slash 22, right? Then this is 12.16. This is 4 plus this is what? 0 slash 22. Look at the subnetwork address. This is what your first address, or else you can say that subnetwork address. What is the subnetwork address? You got 12.16.4.0 slash 22, which is matching with this, right? So 12.16.4.0, which is matching with this, means it is a true statement. It is true statement, right? Then look at the next one. The subnet mask address is 255.255.248.0. Is it correct? Subnet mask address is 255.255.248.0. Look at here, the 22 is the mask. What is the meaning of 22 mask? 22 ones are there. Among the 32 bit of IP address, 22 ones we have to set. So if I set 22 ones, then first 8 ones, next 8 ones, so far 16 ones. Then 22 in the sense another 6 ones I need to set, right? And remaining all zeros. Then this is going to be how much? 255.255.252.0. This is the subnetwork address. But here it is mentioned that 255.255.248.0, which is false. This is false statement. Correct, no? Next. The direct broadcast address of the subnet is 12.16.4.254. So direct broadcast address, what is this other name? Other name for this is what? Last address. You know this, right? Last address. How can I calculate the last address in the CIDR? How can I calculate the last address in the CIDR? I can calculate the last address by setting 32 minus n number of rightmost bits to ones, right? So it means that the last 10 bits, I need to set to 1 now. Look at, I am considering this. So 12.16.4 times of 0, 0, 1, 00, 0, 1, 00, 10, 11, 10, 11, slash 22. The last 10 bits I need to set to 1 here, right? Then it is 12.16.4 times of 0, 0, 1, 11, 8 ones, slash 22. Then this is going to be, how much it is going to be? 12.16. This is 7. This is 255, slash 22. This is the default mask. This is what your direct broadcast address, or is the last address of the subnet. But here it is mentioned that 12.16.4.254, which is incorrect, right? So directly you can say that this particular statement is false. Option C is also false. Option C is also false, right? Next, the valid last host address of the subnet is valid last host address of the subnet. See, this is the last address. Is it valid? No, it is invalid. Then what is the valid host address? Last host address? 12.16. So valid last host address, if you consider, what is that address? 12.16.7.254/22 is the valid last host address. But here it is mentioned that 12.16.4.254, 4.254, but actually it has to be 7.254. So that this statement is also false. So overall, if you verify this question, how many false statements you are identifying? So it is, as it is a MSQ type question, how many false statements we have? Look at B is false, C is false, and D is false. So as we need to find out the false statement here, the answer for this question is B, C, and D. These are all false statements. So this is the answer for this, B, C, D. Okay? So how many have given the answer for this? Let me verify. So what is the answer for this? What is the answer for this? Please verify. All of you. Don't be hurry. Please take your own time. Okay? Please take your own time. Don't be hurry. Okay, so BCD. BCD is the answer for this. Good. It is asking about, Unnati, it is asking about the subnet mask address is 255.248.0. It is given, okay? But what is the mask here? Prefix. What is the prefix ma here? 22. 22 means what? 22 ones must be set. 22 ones out of 32, 22 ones must be there and remaining 10 must be zeros. This is what the meaning of mask bits. So 22 ones means 255 if I convert into binary, I can have 8 ones. 255 if I convert into binary, I can have 8 ones. 8 plus 8, 16 plus 6 ones, total 22. So with the 22 ones, okay, with the 22 ones, I can have, this is the mask. But what is the mask it is given in the question? 248, which is wrong. So that is why the statement B is false. Unnati, are you clear with me now? Yeah, so Shreya also given BCD, very good. Yes, Unnati, I believe you are clear with me, right? Right, so let's move to the next question. So look at this question. This is the question we have from data link layer. Don't be hurry, slowly you can solve this question, slowly you can solve, time is there, it is not an examination, okay? I can wait for your replies. Link is having a bandwidth of 30 kbps. We are using the selective repeat sliding window, which is having 100% efficiency, and the propagation delay is 200 milliseconds. The size of the frame is 60 bytes. The minimum number of bits to represent the sequence number field is dash. So this is the question we have from selective repeat sliding window. Okay, so what is the answer for this? What is the answer for this? Please verify. So what is the given data here? So given data, if you consider, bandwidth is given B, which is 30 kilobits per second, right? And we are using the selective repeat sliding window, which has efficiency of 100%. Fine, efficiency also given 100%. Packet size or else frame size is given 60 bytes. L is given 60 bytes. And propagation time, it is given 200 milliseconds. 200 milliseconds. Efficiency is given, which is 100%. Number of bits in the frame sequence number field, it is asking. Small n we need to calculate. Okay, right. So let us write the point here, that is in selective repeat ARQ or else in selective repeat, if efficiency is 100%, if efficiency is 100%, then what is the condition we have? The condition is W is equals to 1 plus 2A. It is not only in the selective repeat, overall in sliding window. In sliding window, if we have efficiency of 100%, then we have a condition that is W is equals to 1 plus 2A. Where A is, you know that, TP by Tx. Where A is TP by Tx, right? Right. So now look at, so B and L. So this I can consider Tx. Tx is equals to L by B. What is the L? 60 bytes. See, this is given in terms of bytes, but this is given in terms of bits. Need to careful about the conversions. If you commit the mistakes in the conversions, the answer is going to be wrong. So be careful about these conversions. So 60 into 8, I have converted this into bits by 30 into 10 power 3. So 30 2 times, which is going to be 16 milliseconds is the Tx. Okay? TP is already there, which is 200 milliseconds. So now I can calculate the A. What is the A value? TP by Tx. So what is the TP? 200 milliseconds by what is the Tx? 16 milliseconds. So milliseconds cancel. 200 by 16, how much it is? 200 by 16. is 12.5. 12.5. So that we are substituting here, okay? So W is equals to 1 plus 2A, W is equals to 1 plus 2 into 12.5, okay? 12.5. So 12.5 into 2, 25. 25 plus 1, 26. So W is equals to 26. But what is the W? As it is a selective repeat sliding window, what is the center window size? What is the window size in the selective repeat ARQ? That is 2 power n by 2 is equals to 26. Correct, na? Then 2 power n is equals to 52. That equals to 2 to the power of 6. So the number of bits that should be part of the sequence number field is 6 bits. So 6 bits is the answer for this question. 6 bits is the answer for this question. So let me verify how many I have given the question here. Yeah, 26 is the W, but what is the W here, Leena and Shreya? W, the center window size, and the window size in the selective repeat is 2 to the power of n by 2, right? The window size, or else you can say the 2 to the power of n minus 1. Shreya, yes or no? Yeah, so 6 bits is the answer for this question. Yes, very good, very good, very good. Right. So now we are moving to next question, okay? So don't be hurry, please slowly you can solve, don't be hurry, I can wait for all of you, okay? Right. So let's move to next question now. Look at this question, very easy question. Very easy question. What should be the best possible subnet mask if a company requires 222 hosts? This is the underlined one, okay? This is the underlined one. Possible subnet mask if a company requires 222 hosts. Yeah, now I'm expecting the answers from all of you. What could be the answer now? Yeah, window size is 26, correct ma, correct, correct. Leena. Hi Nishu, good evening. Nishu Kumar, good evening. So what is the answer for this? Unnati, Priyanshi, please try to give the answers for this. Nitin, Rishikesh. I'm able to see 15 people online. So please try to solve this question. What is the answer for this? What possible subnet mask if a company requires 222 hosts? Option A, it is given 255.255.0.0. Option B, it is given 255.0.0.0. Option B, it is given 255.255.255.0. Option D, it is given 255, 255, 255 and 255. Okay. See, one thing you have to observe here, it is mentioned that hosts, it is asking about the hosts. Hosts in the sense what you have to consider, try to recall. In classes we used to discuss these points, number of subnets per network, number of hosts per subnet. To find out the number of hosts per subnet, we consider the total number of zeros that are part of the given subnet mask address. So, to find out that number of hosts, there is no need of class, there is no need of thinking of class. But in the case of number of subnets, we need to think of the class. But here, as the question is mentioned about the hosts, as the question is mentioning about the hosts, so no need of thinking of any class, right? So just look into, in the given subnet masks, as it is clearly mentioned subnet mask, among the subnet masks, which one is satisfying the 222 host requirement? This is satisfying, no doubt, because 16 hosts you have. So 16 zeros you have. 16 zeros in the sense 2 to the power of 16 minus 2, which can easily accommodate 222 hosts. And this one also can easily accommodate 2 to the power of 24 minus 2. And this is also can accommodate 2 to the power of 8 minus 2. But this is cannot accommodate 222. So option D is out of race. Their answer is among A, B, C. But as the question is clearly mentioned, best possible, best possible. What is the meaning of best possible? Wastage should be minimum. wastage should be minimum. So if you verify option A, B and C, in which mask, among the given 3 masks, in which subnet mask the wastage can be minimum, that you can easily identify in C. So hence the answer for this question is option C. Option C is the answer for this question, right? So I believe you are all clear with this. Yes, exactly. Nishu have given C, Shreya have given C. Exactly. Kushendra have given C. Good, good. Okay, right. So we can take a break for a short break for 5 minutes, and then we can see the rest of questions. Thank you. So welcome back to the session. Let's move to the next question. Okay. So look at this question, which is based on data link layer and CRC part. So two computers exchanges messages over a link, agree to use the CRC with the generator polynomial, that is x power 3 plus 1, to detect errors. One computer wishes to send the message 1001101. What is the reminder should it append to the message? Option A 100, not 100, 100. Option B 101, option C 110, option D none of the above. So what is the answer for this? So please do calculation of this. Right. What is the message it has given? 1001101. So 1001101, right? One double zero triple one 01. And what is the generator polynomial it has given? X cube plus 1. So message is in terms of binary, but generator polynomial is in terms of polynomials type. Then we need to convert this into binary, right? So for that, what is the maximum exponent of this? It is x cube, na? So maximum exponent is 3, so that the corresponding binary pattern is going to be 4-bit. So if you see 4-bit, since we don't know the 4 bits, you can write it as 0. Then position the x value, x power 1, x power 0, x power 2 and x power 3. Like this we are positioning the x values. And then as x cube is presented in this, so that this bit is 1. X power naught, x square is not there, x power 1 is not there, but x power naught is there, so that this is 1. So now 10001 is the corresponding binary pattern for the given CRC polynomial. So 1001. Okay, right. And since this is a 4-bit length, we need to append 3 zeros to the m of x. So 3 zeros we need to append to the m of x, right? So then we can start modular 2 division technique. So modular 2 division technique always concentrates on the MSB bit. What is the MSB bit here? 1. So that the quotient is 1. 1 into 1001, 1001. So now this is 0, 0, 0, 0. So we are performing the XOR operation, okay, XOR operation here. So now this bit is negligible, then we can add this 1 here. So now what is my MSB bit? 0, so that the quotient is 0. 0 into something, 0. This is 0, 0, 0, 1, XOR operation, right? Now this is neglecting and this 1 we are adding here. So my MSB bit is 0 again, so that the quotient is 0. So 0 into something, again 0. Then XOR operation 0, 0, 1, 1. So this 0 gets cancelled and this 0 we can append here. Now MSB bit is 0, so that quotient is 0. So 0 into something, 0. Then 0, 1, 1, 0. So this 0 gets cancelled after XOR result. Then this 1 we can append here. Then my MSB bit is 1, so that the quotient is 1. 1 into 1001, which is 1001. Then it is 0, 1, 0, 0. XOR operation, okay? Right, so this is cancelled, I mean this 0 is negligible, then we are appending this 0 here. Now MSB bit is 1, so that the quotient is 1. 1 into 1001, which is 1001. Then 1, 0, 0, 0. This 0 gets cancelled and this 0 we need to append here. So MSB bit is 0, so that the quotient is 0. So 0 into something, 0. Then 0, 0, 1, 0. This 0 gets cancelled and this 0 we are adding here. MSB bit is 0. 0 into something, again 0, right? 0, 0, 0. then 0, 1, 0, 0. This 0 gets cancelled, and is there any bit is left? No. So that we are having 100 here. So this is called your CRC. So what we have to do, before starting off modular 2 division, whatever the n minus 1 number of zeros we have appended, these n minus 1 number of zeros are going to be replaced by this CRC while we are transferring to the receiver. So now what is the message that should be transmitted? So message that should be transmitted. Message that should be transmitted to the receiver is, message that should be transmitted to the receiver is, what is this? The format is m of x plus CRC, right now? M of x plus CRC. What is the m of x here? 1001, okay, 1001, then 1101, CRC. What is the CRC we have? 100. So this is the message that is transferring to the receiver. Okay. So among the answers, if you verify, 100 is the CRC that should be appended to the m of x. So that option A is the answer for this question. Option A is the answer for this question. Yes. Priyanshi have given A. Nishu Kumar have given A. Yes. Shreya also given A. Leena have given A. Very good. Very good. And rest of people, please do response. Please do response. Right. So I hope you are clear with the explanation of this question. Let's move to next question. Okay. Right. So look at this question. This is the question we have from data link layer, flow control. A link has a transmission speed of 50 Mbps. Assume acknowledgement has negligible delay and its one-way propagation delay is 2 seconds. Also assume that the processing delays at nodes are negligible. If data packet size is 10 power 7 bits, then the efficiency of go back 15 protocol is, what is the answer for this? Efficiency of go back 15 protocol is, please do slowly, don't be hurry. Okay, please do slowly, don't be hurry. So what is the answer for this? Right. So let's consider the given data here. What is the given data? The transmission speed of 50 Mbps. You know, what do you mean by transmission speed? Bandwidth is also called as transmission speed, transmission rate, bit rate, data rate, channel capacity, transmission rate, etc. Right? So bandwidth is given as 50 Mbps. Assume acknowledgement has negligible delay, fine, and its one-way propagation delay is 2 seconds. So TP value is given, which is 2 seconds. Also assume that the processing delays at nodes are negligible, fine. If the data packet size is 10 power 7 bits, L value is given 10 into 10 power 6 bits. And window size is given 15. Window size is given 15. And it is asking us to calculate efficiency. Right? So tell me in go back n, what is the efficiency formula we have? So as go back n is also a kind of sliding window, okay? As go back n is also a kind of sliding window. So what is the formula we can write? In sliding window, in go back n, the efficiency nu is equals to, efficiency nu is equals to W by 1 plus 2a. W by 1 plus 2a. Where W is what? Where W is what? 2 power n minus 1. This is the formula for efficiency calculation, right? But W value is already given in the question statement, okay? Right, we need to calculate only A part, right? So what is the A value here? TP by Tx, you know, right? So TP is already there, but Tx is not there. We are going to calculate the Tx. So Tx is equals to L by B. What is the Tx? What is the L here? 10 into 10 power 6. by bandwidth 50 Mbps, 50 into 10 power 6. So as it is in terms of seconds, let us express this Tx also in terms of seconds. 10 power 6, 10 power 6 cancel, 10 by 50. So 10 by 50, or else you can say 1 by 5. 1 by 5 I believe it is 0.2. Let me verify. 0.2, good. So 0.2 seconds is the Tx value. Right, so now I can calculate the A because Tp is ready and Tx is ready. So Tp by Tx. What is the Tp? 2 seconds by what is the Tx? 0.2 seconds. So then this I can write as 2 by 10, which I can write as 20 by 2, which is 10. So A value I am getting as 10. So therefore, what is the efficiency now? Look at. So efficiency nu is equals to W is what? 15 by 1 plus 2 into 10, which is 15 by 21. So what is the 15 by 21 value? So 15 by 21 if you do, you are getting 0.714. 0.714. So if you express this in terms of efficiency, I mean in terms of percentile, you can get 71.4%. So 71.4% is the answer for this question. So consider that we are expecting the answer in terms of percentages. Okay, so efficiency we are expecting in terms of percentage. So what is the answer for this question? The answer is 71.4%. Yes, Nishu have given 71, Sanjay have given 71, Shreya have given 71. Very good, very good. Leena given 71. Very good. Right. So let's move to next question. Okay. So look at this question. It is given from network layer. It is the question we have from network layer. IPv4 addressing. So what is the answer for this question? Please verify. I'm sure I am telling you, if you attend these sessions, preparation league sessions, you can recall all subject. I mean, in 2 sessions, you can recall all models of numericals which are part of this computer networks. Okay. So, and please participate in the sessions. Participation in the sense you need to send the responses. If you are having doubts, you can post them. Don't worry about that. Okay. And if any point is not clear, you can ask. Don't worry. How I am getting the so and so value. For all of them, I can respond. Don't worry. Right. So look at this question statement. A block of addresses is granted to an organization. One of the address is 192.18.41.177/26. If X is the last octet of the first assignable address and Y is the last octet of the last assignable address of this subnet, then X plus Y is dash. Right. So look at this question statement. How we can solve. It is given that the block address is this one. So 192.18.41.177/26. So it is asking about the X is the last octet of the first assignable address and Y is the last octet of the last assignable address. So it means that we need to find out the first address and last address. As it is a CIDR representation, first address, how can I calculate? To find out the first address, I need to set 32 minus n number of rightmost bits to the 0, right? So 32 minus n, what is the n value? 26. So 32 minus 26, 6. The last 6 bits I need to set to zeros, okay, to find out the first address. Look at. So first address I am calculating. So 192.18.41.177. How can I write? 128 plus 32, 160 plus 16, 176, and then this is 0. This is 177, I believe. 10110001. This is 177 slash 26. Then this could be 192.18.41. Last 6 bits I need to set to 0. These are the 6 bits I need to set to the 0. So if I set these 6 bits to the 0, then I am getting what is the first address here, 192.18.41 and 128 slash 26. So this is the first address I am having. But is this address is assignable? No. Then what is the assignable address? The assignable address can be 192.18.41 and 129 is the assignable one. So this is assignable first address. Assignable first address. Okay, and it is asking about if X is the last octet of the first assignable address. In the first assignable address, what is the last octet? 129. So 129 is the X value here. Then similarly, we are going to find out the last address. Look at how can we calculate the last address. So 192.18.41 177. How can I write? 10110001 slash 26. So last 6 bits I need to set to ones here. So 192.18.41 10 last 6 bits I need to set to 1 here slash 26. Okay. So then this is 128 plus this is 63. So 128 plus 63, how much it is? 191. So 192.18.41.191, correct now? 191. 128 plus 63, 191 slash 26. This is the last address. But is it assignable address? No, this is not assignable address, right? But what is the assignable address? Last assignable address, you can say 192.18.41.190 slash 26 is the last assignable address. This is the last assignable address. So if you consider this is the last assignable address and it is asking about last octet of the last assignable. What is the last assignable octet? Last octet of the last assignable address is 190. So this is Y value. So X is 129 and Y is 190. So X is 129 and Y is 190. Then what is that answer? 91319. So 319 is the answer for this question. 319 is the answer for this. Yes, Nishu have given 319. Sanjay have given 319. Very good. What about remaining? Shreya, Leena, Priyanshi, Unnati, Chandra. Right. Good. So 319 is the answer. Very good. So let's move to the next question. Okay, let's move to the next question. Right. So look at this question. This is based on simple concept of layering. You can find bit difference in this question. A 1000-byte message is sent over network using a protocol stack with HTTP, TCP, IP and Ethernet. Each protocol header is 20 bytes long. What percentage of the network bandwidth on the wire is used for the message data? Give a numeric answer only. So what is the answer for this? Please verify. What is the answer for this? Unnati, the first address we call it as network address or else subnetwork address, and the last address we can call it as broadcast address. So broadcast address is a special address which cannot be assignable to the system, and network address or else the subnetwork address is also a special address which cannot be allocated to a host as a normal IP address. Okay, so that is why we are doing subtraction here. Two, first and last are not allocated, not assignable. I hope you are clear with me. 192, why we have not taken is 191 is the last address of the particular subnet. We is clearly asking about, look at, it is clearly asking about, what is this line? Okay? Nothing. Right. Right. So what is the answer for this question? Yes, Sanjay have given 92.5. Very good. Right. So let us think about this question. Message size is 1000 bytes. M is given 1000 bytes. Is sent over the network using a protocol stack HTTP, TCP, IP and Ethernet. Each protocol header is 20 bytes. So via how many protocols this message is been traveling? 4 protocols. All these 4 protocols are appending their own headers which are having the length of 20. It means that this 1000 bytes getting added by the 80 bytes of header. So it means that the total message that is going to be placed onto the network is 1080 bytes. 1080 bytes of data, 1080 bytes of message, which is inclusion of data portion and the header portion. How many headers? It is 4 headers. Each header length is how much? 20. So 4 into 20, 80. Plus this message. Total 1020 bytes of this length message is being keeping onto the channel. So this is the channel here. Okay. So then this answer, what is the question it is saying? What percentage of the network bandwidth on the wire is used for the message data? It is asking only for the message data. What percentage of the network bandwidth that is used on the wire for message data? So message data in the sense, out of this 1080 total, what is the message you have? 1000 bytes. So this is what the percentage of network bandwidth on the wire that is used for message data, which is 1000 by 1080. So what is the 1000 by 1080? 1000 by 1080, if you verify, it is 92.5 percentage. So 92.5 percentage. So this is the answer for this question. This is the answer for this question. For example, if I ask what percentage of the network bandwidth on the wire is used for headers, if I ask, what is the answer? If I ask headers, for only headers if I ask, then what is the answer? So simply if I ask headers, then it is going to be 80 by 1020. This is the percentage, right? If it is a data portion, this is for message data, but this is the headers one. Am I correct or not? Right. Yes, Lena, it is 1000 by 1080 for message data. But if it is asking about the headers, then it is 80 by 1080. Okay? Right. Yes, exactly. Exactly, Nishu. So I hope you are clear with this question and its corresponding explanation. Let's move to next question. Okay? So look at this question. MCQ, which is from network layer, IPv4 addressing is the subtopic. Look at the question statement. Identify the valid hosts in any subnet of 192.162.30.0, assuming the subnet mask used is 255.255.255.240. Option A, 192.162.32.119. Option B, 192.162.32.126. Option C, both A and B. Option D, neither A nor B. So what is the answer for this? It is clearly asking about identify the valid host in any subnet of this. Any subnet of this. Okay? Right. So please look into this answer. Let me know what is the answer for this. So look at here, it is given that the subnet is, what is the subnet address? It is, what is the, identify the valid host in any subnet of this 192. So let's say IP address is given. What is the IP address here? 192.162.32.0. And subnet mask address is given. What is the subnet mask address? It is given 255.255.255.240. So when I have an IP address and subnet mask address in the question, what I can calculate? I can calculate the subnetwork address. So now subnetwork address is equals to, what is that? You know that if the mask byte is 255, set the corresponding byte to the result. You know that, masking rules, right? If the mask byte is 255, set the corresponding byte of an IP address to the result. If the mask byte is 0, set 0 to the result. Look at what is the mask byte here, 255. So that set the corresponding byte of an IP address to the result, which is 192. Mask byte is 255. Set the corresponding byte of an IP address to the result, which is 162. Again, mask byte is 255. Set the corresponding byte of an IP address to the result, which is 32. And this is the mask byte which is neither 0 nor 255. Then what should we do? We need to perform the logical AND operation between this byte and this byte. So 0, if I convert into binary, it is 8 zeros. 240, if I convert into binary, 4 times of 1 and 4 times of 0. Then if I perform logical AND operation between these, I can have 8 zeros, which is 0. So 0 is the result. So now I have to divide this subnetwork address into 3 portions. 3 portions in the sense, network ID portion, SID portion and HID portion. So 192.162.32, you know, from network ID portion, from where I can get the network ID portion in the subnetwork address from the class of IP address. What is the class of IP address here? Class C. So since class C IP address it is, how many bytes of network ID we have? 3 bytes. So total these 3 bytes are comes under your NID portion, right? Then this is what your HID portion. That HID portion I am writing 8 zeros. So this I am converting. So this subnetwork address I am considering here. Okay, right. So now NID is defined. Then I need SID, which is subnet ID. So subnet ID from where I can get? I can get the subnetwork ID from the subnet mask address. So what is the subnet mask address here? 255, 255, 255, 240. So you know that default mask address of class C contains 24 ones. But here in the subnet mask address, in the given subnet mask address, I have 28 ones. So 4 are extra. So those 4 extra ones, in which byte I am getting? So those 4 extra ones I got in the last byte of this given subnet mask address. So this last byte I am converting into binary. So if I convert this last byte into the binary, so these are the 4 extra bits. I mean, these are the 4 extra ones that are added to the default mask address of class C. So for these 4 extra ones, what are the corresponding 4 bits in the subnetwork address? These are the 4 bits. So that this is my SID portion. And once NID portion and SID portion is defined, then the remaining portion is my HID, right? So this is the way how you can define this. So now it is asking about a valid host. So what is the meaning of valid host? The host ID portion of these addresses, the host ID portion of these addresses should not be all zeros and all ones, right? So now consider this first IP address, 192.162.32 and 119. 119, if I convert into binary, how can I get this? What is the binary format of this 119? 119, 0, 64, 96, 112. So far it is 112, then 7. So this is my 19, 119, right? And if you consider this 126, how can I write? 0, 111, this is 112, 112 plus 14. 14, how can I write? This is 14. So if you verify, the last 4 bits of 119 is not all zeros and not ones. These are not all zeros and not ones. It means that this is a valid address. Next, 126 if you consider, this is also not having all ones or else all zeros, as the last bits, last 4 bits are not all zeros and all ones. So that this is also a valid address. So since both are valid, option C is the answer for this question, both A and B. So let me verify what is the answer for this, people. Yes, Shreya have given option C, Sanjay have given option C, Priyanshi given D, Ma Priyanshi verify, Leena C. Yes, okay, very good. So I hope you are getting the concepts, you are able to recall the concepts, right? So let's move to the next question. So look into this theory based question, very simple question from concept of layering. What is the answer for this? What is the answer for this? Which of the following OSI layer is responsible for converting raw bits into frames and vice versa? So what is the answer for this? Yeah, Unnati have given B, Sanjay have given B, Leena have given B. Yes. So the answer for this question is no doubt option B. Option B is the answer for this. Try to recall the responsibilities of data link layer. Responsibilities or is the functions of data link layer, if you verify. First functionality is PDU. What is the PDU of data link layer? The PDU of data link layer is frames. So frames. So it means that it is responsible for framing. What is the meaning of framing? What is the meaning of framing? The process of converting numeric character stream into frames is said to be framing. So to do this framing procedure, data link layer is having two techniques. What are the two techniques, or else what are the two classifications of this framing? One is static framing, another one is dynamic framing, right? So static framing, what is the example we have? Character count. We have character count. And what is the example we have for the dynamic framing? Character stuffing and bit stuffing. Correct now? So character stuffing and bit stuffing. So these are all the framing techniques which we are using to convert raw bits or else numeric character stream into frames. So option B is the answer. And rest of functions, if you verify, data link layer is responsible for error control. Data link layer also responsible for flow control. Data link layer also responsible for access control. Data link layer can provide physical address. And data link layer also responsible for node to node delivery. So these are the responsibilities we have with respect to this data link layer. So if you recall these functions of data link layer, you can easily answer this question as option B. Okay, option B is the answer for this. Yeah, Unnati. PDU, which stands for Protocol Data Unit. Protocol Data Unit. So in simple format, in simple language, you can say instead of PDU, you can also say the data format. The data format that is supported by the data link layer. The data format that is supported by the data link layer is frames, or else the PDU of data link layer is frames. Okay, right. So I hope you are clear with this, Unnati. Right. So next, coming to the next question. Let's move to the next question. Right. So look at this question. IP addresses are considered network addresses with a /26 prefix. MCQ. It is given from network layer concept, IPv4 addressing subtopic. So what is the answer for this? What is the answer for this? See, it is clearly mentioned that /26 as the prefix. So what does it mean? 26 mask bits are there. 26 mask bits. In all these IP addresses, 26 mask bits are there and 6 bits are host bits. 26 mask bits are there in all IP addresses, okay, and 6 host bits are there. Those 6 host bits must be 0 because it is clearly mentioned that network address. Network address. What is the format of the network address? Try to recall. The format of the network address is NID portion is specific. NID portion is specific, but HID portion contains all zeros. This you know. So host ID portion, what is the host ID portion among these 4 addresses? Host ID portion is last 6 ones, last 6 bits. So if you verify last 6 bits, means no need of converting this into binary, this into binary, this into binary, enough to convert this 255 into binary. If I convert this 255 into binary, I am getting 8 ones. So 8 ones and the last 6 bits if you verify, all are ones. So all are ones, but actually it is saying that network address means the host ID portion should contain all zeros. So that this is not an answer for this. Then 191. So 191, if I convert into binary, if I convert this 191 into binary, what is that 191? I believe 191 I can write as 128, 0, then it is all ones I believe. This is 191 I believe, right? Yes, 128 plus 63, yes, 191, right? So these are the 6 bits if you verify, all are ones. Means that this is also not a network address. Then 165.205.6.63. 63 if I convert into binary, 63 how can I write? This is 63. This is 63. So last 6 bits if I verify, these are all again all ones. But according to the network address format, the host ID portion should fill up with all zeros. Then 192 if you verify, if I convert this into binary, 111 6 times of 0. Last 6 bits if you verify, all are zeros. Right? So hence the answer for this question. So this option A is following this format exactly. So option A is the answer for this question. So I believe you are clear with this. Sanjay, verify Sanjay. Yes, yeah, Leena have given A, Priyanshi have given A, Vannati have given A. Very good, very good. Nishu, are you there? Give me the answer. What is the answer for this, Nishu Kumar? Option A is the answer, right? Right. So let's move to the next question now. So look at this question. This is the question we have from data link layer. Consider a network connecting two systems located 3000 kilometers apart. The bandwidth of the network is 100 Mbps. The propagation speed of the media is 2/3 of speed of light in the vacuum. It is needed to design go back 127 sliding window protocol for this network. The average packet size is 10 kilobits. The network is to be used to its full capacity. Assume that processing delays at nodes are negligible. Then the minimum size in bits of the sequence number field has to be. So what is the answer for this? So what is the answer for this question? So here the question is given, the given data, if you collect given data, the bandwidth is given 100 Mbps. And distance is given Packet size is also given 10,000 bits. 10,000 bits. Distance is given D, 3000 kilometers. Propagation speed, it is given 2/3 of speed of light in the vacuum. So 2/3 of speed of light in the vacuum, how can I write? 2 by 3 into 3 into 10 power 8. So 3 gets cancelled, 2 into 10 power 8. So I am getting here V as 2 into 10 power 8. Okay? Right. It's clearly mentioned the network is to be used to its full capacity. It means that the efficiency is given as 100%. Okay. So from these two we can calculate the Tx. What is the Tx value? L by B. L is 10,000 bits. So 10 into 10 power 3 by 100 Mbps. 100 into 10 power 6. 100 into 10 power 6. And Tp is D by V. So what is a D? 3 into 10 power 6 by V 2 into 10 power 8. 10 power 8. So 10 power 8 I can write like this. Okay? Right. So then what could be the answer now? So if you want me to express this in terms of microseconds, okay, so then it is going to be 100 microseconds it is. Correct? 100 microseconds it is. And this is going to be 30,000 by 2. 30,000. So this is 10 power 4. 30,000 by 2 if you calculate. So what is the answer? 30,000 by 2. 15,000. Right? So 15,000 microseconds here. Right. So then Tx is ready, Tp is ready. I can calculate the A value. So what is the A? Tp by Tx. So Tp is 15,000 microseconds by Tx is 100 microseconds. So this cancel, this cancel. I am getting 150. 150. A is 150. And you know that in go back n or else in sliding window, right? If efficiency is given as 100%, then what is the condition we have? W is equals to 1 plus 2A. So that implies, what is the W? In go back and the W is to the power of n minus 1 is equals to 1 plus 2 into 150, which is to the power of n is equals to the power of n minus 1 is equals to 301. So this I can write as 2 power n is equals to 302. So now tell me for what value of n I can have 302 frames, that is 9 bits. So n value is 9. 9 is the answer for this question. 9 bits is the answer for this. So how many of you given 9? Let me verify. Yes, Sanjay, no doubt it is 9. Exactly. Right. So let's move to next question. So look at this question statement. It is from network layer and the subtopic is IPv4 addressing and it is MSQ. You are a network administrator and have been assigned the IP address of 205.222.5.0. You need to have 28 subnets and with 6 hosts per subnet. The subnet mask is 255, 255, 255, 248. Which addresses are valid host addresses? So the first address it is given 205.222.5.17. The second address it is given 205.222.5.18. The third address it is given 205.222.5.16. The fourth address it is given 205.222.5.19. And fifth address it is given 205.222.5.31. Option A 124, option B 125, option C 245, option D 345. What is the answer for this? Yeah, there is no significance with that 127 because the window size is we are calculating here, right? It is given already. Just to say that go back N protocol, it is saying, okay, for that purpose. Sanjay and Vannati, I believe you are clear. There is no significance with that 127. So start answering this question. So, what is the IP address we have? The IP address we have here is 205.222.5 and 0. And the subnet mask address we have 255, 255, 255 and 248. So, we are calculating the subnetwork address here. So, what is the subnetwork address now? Mask byte is 255, so that set the corresponding byte of an IP address to the result, which is 205. Again, mask byte is 255, set the corresponding byte of an IP address to the result, which is 222. Again, mask byte is 255, set the corresponding byte of an IP address to the result, which is 5. But this mask byte is neither 255 nor 0. Then what should I do? I need to perform the logical AND operation between these two bytes. So, 0, if I convert into binary, I am having 8 zeros. 248 if I convert that into binary, 5 ones and 3 times of 0. Okay. So if I perform logical AND operation between these two, I am going to get 5 times of 0 and 3 times of 0, which is 0 only. So the last byte is going to be 0 only. Right. So now after calculating the subnetwork address, I need to divide this subnetwork address into 3 portions. So now I am going to divide this into 3 portions. So, as it is class C IP address, first 3 bytes belongs to network ID. So, 205.222.5 is comes under my network ID. Okay, and this is 8 zeros. So, the last byte I am converting into 8 zeros. Okay, right. And after defining the network ID, I need to define the subnetwork ID. So then coming to the subnetwork ID here, look at the subnetwork ID. What is the length of the subnetwork ID here? Look at, to find out the subnetwork ID, I need to concentrate on the subnet mask address. What is the subnet mask address here? 248. So 248, how can I write? 5 times of 1 and 3 times of 0. So as per the default mask address of class C, I am having 24 ones. As per the default mask address of class C, 24 ones must be there. But how many ones I am having? 24 plus 5, 29 ones are there. Means 5 ones are extra. So these 5 ones, extra ones, for these 5 extra ones, what are the corresponding bits I am having in the last byte of this subnetwork address? If you verify, these are the 5 bits are corresponding bits. So that this is my SID portion and this is my HID portion. So now the HID portion is 3 zeros. So the HID portion is 3 bit. So among the options, whichever option is not going to have all zeros and all ones, that option is the valid. And which option is going to have, which IP address is going to have the last 3 bits as ones, they are called invalid addresses. So if you verify, so 17 if I convert into binary, this is 17. So last 3 bits, if I verify, last 3 bits are 001, which is not all zeros and not ones. So that this is a valid address. So first one is valid. But among the options, option C is not mentioned 1. Option D is also not mentioned 1. So that C and D can be ignored here. Then we have A and B, right? So next coming to the 18. So 18, how can I write? If it is a 17, then 18, how can I write? 16 plus 2. This is 18. Look at now the last 3 bits. Last 3 bits also, not all ones and all zeros. So that this 18 is also a valid address. Next 16 if we verify. So 16 in the sense this is 16 here. So last 3 bits if we verify all are zeros. So that this is invalid address. This is invalid address. Next 205222519. So 19 how can I write? 16 plus 3. 16 plus 3. So 16 plus 3. Look at. Last 3 bits if we verify, these are all not all zeros, not all ones. So that this is also a valid address. But when it comes to the 31, 31 how can I write? 31 how can I write? This is 31, right? This is 31. So last 3 bits if I consider, all are ones. But according to the, to say an IP address is valid with respect to this subnet mask address and with this subnet record address, to say IP address is a valid, what does it mean? The host ID portion should not be filled up with all zeros and all ones. But here it is filled up with all ones, right? So since it is filled up with all ones, this is going to be, you can say that invalid. This is invalid. So fifth one is invalid. So option B, it is mentioned fifth one, so that this is ignored. So then what is the remaining answer? Option A, 1, 2, 4. So look at 1, 2 and 4 are valid addresses. Option A is the answer for this question. Okay. So I believe you are clear with explanation of this question. Let's move to next question. So as this question is going to take some more, much more time, okay, so we can see this question in our next session. So I hope you have enjoyed the session and you are able to recall all the concepts with respect to this data link layer and network layer. Okay, thank you. And so if you people are interested to take up ACE products with respect to online GATE and ESE courses, try to use this referral code to get discount of 15%. Okay, right. Have a nice day. Thank you.